Okay, welcome back. So today we're going to finish this lecture. I'm not going to start it all over again from the beginning. But you guys were all here last time? Okay, good. So I don't have to review anything, probably. But it's always weird to start a lecture right in the middle of it without kind of at least bringing, some reminders about what I was talking about last time. Was covering cloud computing and the concept of it, and I defined what cloud computing was, and in terms of it being described as kind of an upgrade to utility computing. So it takes place over the internet. Basically, it's set up as from utility computing, which is where it kind of gets its functionality from. It's more of a platform, though, instead of a computing environment. And so it uses the internet to communicate, transport, provides hardware, software, networking services, and stuff like that in terms of the platform. And then we have an API for application programming interfaces that happens via the cloud. And I think I talked about why we wanted the cloud, what the cloud is useful for in terms of demand services. Talked about the remotely hosted, ambiguous kind of, we don't know exactly what server we're on. We're just connected. And then that separation with the application in terms of nowadays with the cloud we don't actually see the application itself running in terms of an application that we're going over and we're trying to use. Rather, instead, we're accessing it through the platform, through the cloud. So this infrastructure here, we covered that. We looked at the cloud itself in terms of the architecture, the service value network that writes on top of the platform for the services, that writes on top of the infrastructure. So the hardware, middleware, cloud-ish middleware, and then we have the applications that run on it. And I started defining some of the different computing layers. And the left-hand side is kind of showing you the terminology. The right-hand side is giving you some examples of some of the ways that, or some companies, I should say, that are implementing some of the concepts. In terms of the server platform, we always think of grids. In terms of storage, we always think of remote disks or iDisks kind of things. Applications, all the Google apps are cloud-oriented these days. Google Docs, sharing, collaborative environment, anything that's working in a collaborative environment. The application services, and in terms of MS Live would be a good example of that. And some of the Google apps fall into that category as well. Then I looked at the service layers in terms of the cloud environment. We had the application focus versus the infrastructure focus in terms of the way that the platform can be divided out into multiple sections. With the concept of this abstraction, this reminds a lot of people about like the TCP/IP layering, stack protocols and stuff. If you're a networking person, it's kind of presented in the same kind of way. It's kind of a hierarchy or a stack, if you want to think of it that way. We have the hosting, we have the storage, we have the platform, which is really part of the infrastructure. So when we subscribe to the service, we're getting that. And then what's different normally is the development, the application, and the services that are running in this particular environment. So depending upon, and then I hate to mention it, this is probably all going to change anyway in the future. And what I'm pointing to here is like, as example for services, I don't think PayPal is going away at all. That'll probably stay. But some of the other, Google Maps and stuff, well, that probably will stay as well. But some of the other small guys come and go. And these are just examples in terms of a description. And it's better just to provide an example these days, assuming that you've used some of the Google Maps or some of the PayPal and you're familiar with what the services are. Because it could take forever, actually, to kind of describe all of those different companies and different functionalities, which I think is why people have a hard time understanding what the cloud is. And I think a lot of people have heard of the concept, but they have never actually probably thought about it in terms of the infrastructure. But in terms of strategic management information technology, not a bad idea to be familiar with it so that you can utilize it in a business environment. So here's some basic cloud characteristics. There is a no need to know, which means although I'm telling you what this all is all about, you don't really need to know it in order to use it. So the term is the underlying details of the infrastructure, the applications, the interfaces, the infrastructure themselves. Everything is accessible through the API interface, application programming interface. So you can build applications that run with this cloud without having to know anything about the abstraction, or excuse me, anything underneath the abstraction of the concept. So we have flexibility, elasticity. We're able to, or allow systems to add on different storage units, take away storage units, do load balancing, use databases, mix and match. And then it's also a pay-as-you-need or pay-as-you-use type of environment, which gives us our service-oriented utility. So hopefully in the future, most applications will be released this way. So instead of buying a piece of software and installing it on your computer, you're subscribing to a service, and you're only paying for how many hours you use it, which is kind of a different concept than how we approached software in the past. And so we have a transparent to users and the application. It's just there as a middleware and can be built in multiple different ways, different brand products. I assume eventually we're going to come down to one or two cloud components, and that'll be pretty much the de facto standard in the industry. But right now we have a lot of small-time people that are in there who are experimenting with different cloud platforms. And the term has actually become as common as object orientation is. Everybody calls everything everything. Well, everything's cloud, everything, even if it really isn't. But actually, the definition of what the cloud entails is so broad. Everything could actually be considered. If it's a networking application, it's providing a middleware interface, a seamless transition from the user to the application. Sounds like a cloud to me. So in general, built on clusters of PCs, clusters of servers, computers all together that create the abstraction of the infrastructure, or the abstraction of the hardware layer on it. Okay, so here's some of the definitions, and I think I probably stopped around here. Maybe it's probably where I stopped. Okay, good. Trying to review just to get everybody kind of up to speed. Especially if you're watching the video and you you missed the first part. That's all you missed. So okay, so SaaS, software as a service. I've never actually seen anyone in real life use that term. It looks funky to me. The two A's don't look right. But software as a service, and you hear service-oriented software. You hear utility computing. But I never hear service as a service. I can't even say it. Software as a service. But theoretically, that's what you've got. I believe I've explained that kind of already in terms of the concept. So it's hosted on a server. You access the server. You use the software across the network. So you're not really installing anything locally on your computer. So it's used to refer to business software rather than customer-related software. And it falls under the Web 2.0. And I'm assuming, I think I talked about Web 2.0, 3.0, maybe last time. Did I talk about that in this class? No? Do we know what Web 2.0 is? No? Oh, then let me talk about Web 2.0 because this cloud concept is Web 2.0. So, Web 2.0, we've actually kind of seen it with smartphones, with Windows 7 widget items on the desktop, with utility software. What it is, it's kind of breaking the seam between using the internet in terms of the user going out to use the internet. That's Web 1.0. Web 1.0 is your web browser, is your FTP client, your telnet servers, your Unix was 1.0. 2.0 is the internet is now coming to us instead of we're going to the internet. So we get, in Windows 7, there's these things called widgets. Are you familiar with that at all? Widgets? Have you heard of widgets? Okay, good. Widgets sit on the desktop. Sometimes they deliver weather information. Like right now, we say it's raining outside. Yeah, like you can look out the window and find out yourself. But it's getting the information from the internet. So if you lost the internet, connection from your computer, your widget wouldn't work, essentially. So now the computers are connected 24 hours a day, 7 days a week, constantly. We can have internet-enabled applications that, without us going out to the internet, it comes to us. And it gives us information like the weather, gives us stock prices, movie listings, feeds us, hey, you got a new message. And so when I talk about Web 2.0, I always think about smartphones, because that's what's going on the smartphones. You already have a data connection. That phone's turned on, it's using, you have a data. it's fully connected 24 hours a day, 7 days a week. It can populate items and give you information, which is the essence of 2.0. 3.0, you can't tell it's on the internet or off the internet. So 1.0 is we go out to the internet, 2.0 the internet comes to us. 3.0, it's here, but we're all in one world now. We've converged the real world with the internet world. So 3.0, there's a lot of virtual reality functionality with that. There's some with 2.0, but not as much. We haven't really seen too many 3.0 applications yet, or 3.0 concepts, because it's really kind of a wave of the future. It's appliances, anything, any device already being internet aware, already being on the internet. And then real life is also on the internet, off the internet. We can't tell the difference. Right now we can tell the difference. So we're still in 2.0. But theoretically, the cloud is 2.0. Because the cloud is populating itself with information, services, features that we're using with our applications, with our programs. And it's kind of a seamless interface in terms of the user to this middleware. So by removing the need to install and run applications on the user's computer, we're now in 2.0, because we don't actually have to install something, and we don't have to actually go out to the internet to get it. It's coming to us automatically, which is nice. And so the software as a service interface alleviates the burden of the software, essentially. So I think hopefully I've covered that enough so you can get an idea of how the terminology is working is really what you need to kind of get a feel for. Virtualization. So I think I actually looked at this a little bit last time in terms of, but I didn't really explain very much about it. In terms of the virtual VM, the virtual machines, and in terms of the architecture, the cloud gives us a VM, actually. And the concept works with the abstraction of there being an operating system on top of an operating system, independent of the operating system underneath it or the hardware underneath it. It's kind of like running your phone on your computer, if you think about it, or running Windows on a Mac or Mac on a Windows, which we have already, actually, through virtual machine software like VMware or Parallels or some of the other programs out there. So the cloud also gives us the virtual machine environment, because we can use it with a Mac, with a PC, but we can also use it with other kinds of things. Instead of desktop or notebook computers, we can use it with watches, or cell phones, with electronic devices of any sort. So. And in terms of the virtual machine environment, here's kind of the way it looks. And what we're looking at is stacking information on top of information. So it allows multiple virtual machines to run on a single physical machine. So we're really just creating a higher level of abstraction from a software perspective, still running on the hardware, same hardware actually, and different hardware supporting different kinds of configurations. I'll tell you the biggest problem with virtual machines is performance. The biggest problem with the cloud right now is performance and security, if you think about it. Which is why I wouldn't say that the growth's been slow, but it hasn't been as fast as a lot of people would have expected. Because think about the concept of sharing information and not knowing exactly where it's going. So you upload your pictures to the cloud, there's the Windows Live or the Windows networking kind of environment, and you don't know where they're going exactly. You don't know what server they're being stored on, or exactly who's going to be able to see them. And in a lot of cases, you can't really control that. Unless you actually have something on your computer housed under your safety, under your control, there's absolutely no way of you personally being in control of it. And a lot of people have a problem with that concept. But we've been doing it already. Your Gmail account, all of your email addresses, everything, even everything you send and receive, is stored on a public server with public access. But people don't care about that. So people only care about getting free email service, which is not bad. It's a good service, actually. So, and even like your MySpace usage and stuff, or your Facebook usage, all that stuff is public. So the concept of, well, who owns it? Depends on your contract, depends on what you sign. So imagine these are just applications that people are choosing to use. You don't have to subscribe to Facebook. You don't have to use Gmail. You can use your own other stuff. You have choices, right? If we moved everything in terms of utility, going back to the concept of this utility transformation where we don't put software on our computers anymore, we may not have a choice. Which, it's kind of like follow the bandwagon or get off the internet. But now with Web 2.0, we're on the internet constantly. It's coming to us. So we're losing some individual choices, which is why I believe it's one of the reasons why it's being held back a little bit. We're not seeing as many cloud applications as we would probably see if we didn't have those actual kind of problems that are associated with it. So. And I shouldn't say that they're problems. They're characteristics that are changing the nature of computing. So I talked about the virtual machines. So what's the purpose and the benefit, essentially? So this basically breaks down to, and what I'm leading to is, why do we even want this? If we have no security, it's shared to everybody, we have no control over it anymore, all of a sudden our entire world becomes public knowledge. Everything on our computer is now accessible to everybody else in the world. If we like it or not, if we're using it, why do we even want that? Well, information is knowledge. In terms of information technology and what we're looking at in this class, we have strategic advantages that we can apply. With that information, applying the technology to it, we can get all sorts of information about consumers, about products, services. We can even provide services that weren't provided before. So the cloud computing enables companies and applications which are system infrastructure dependent to be infrastructure-less. So we can put a platform out there like a Salesforce.com and take away the platform restrictions and make it accessible to everybody. So we give everybody a common platform to cloud, put the utilities out on the cloud. You got access to the cloud, you got access to the utilities. Makes things easily accessible to people without having any type of hardware restriction or infrastructure restriction, which breaks the barriers. We've seen it traditionally, an example of how this is going to revolutionize computing. We have to think backwards and say, well, what's happened in the past? Well, in the old days, we had credit cards, right? We were able to use credit cards and swipe the card, magnetic strip, type in the number, and run to a machine. And so now I can use it on the computer, right? We just type in the number now, right? Now we have companies like PayPal, which is an excellent example because their cloud service software, use it as you need it type of utility, and you do pay per transaction that you process through PayPal. But the concept is you're not using a credit card anymore. You're using something that's compatible among all different merchants. That's an electronic cash that gets converted to real cash. You can actually keep PayPal money in PayPal and use your balance. It's actually kind of a way of mixing this platform dependent into a platform and an infrastructure independent thing. You can use it with any website, with eBay. You can use PayPal back and forth to send people money back and forth. Just instead of doing a wire transfer, you can use PayPal now, actually. So there's a bunch of services and things that are infrastructure-less, platform-less. That's one of the original examples. Now think of other computing needs. This is the tough part. Companies now have to think, what can we do similar to the PayPal? Well, how can we do other things? Well, when you buy movie tickets or something, there's companies experimenting with different ways of buying the tickets. So we had Fandango, and we had some of the. You walk up, you swipe a credit card on the side. You don't have to talk to a person. Now I actually have a touch-tone apps, a touchpad apps that you walk up and you wave it, and you pick which one you want. And instead of talking, you're ordering, and then you pay with a credit card that's already listed in the system, and then you just pick up the ticket. So you don't have to touch or you have to swipe any machine either. You just stand in the vicinity with your phone and process your ticket. Well, it's running on an infrastructure, it's running on a cloud infrastructure that's connecting all of these little pieces, your cell phone as a remote, your bank account, your credit card account, their system, the whole payment, the entire scheduling of the content of the movies you're picking from. All of these different things are kind of integrated into one. especially, I kind of like the concept. They have it at Sun's Arena now. You order tickets online. It sends, on your phone. You hold your phone up, and they barcode scan the barcode that's showing up on a picture, and then that's your ticket. You're gonna carry your phone anyway, probably. If you got it on you, why carry a paper ticket too? It's already on your phone. So. But you can think about it. Not everybody's into that. I can think of a lot of non-tech kind of people that don't want all that technology thrown at them. Problem with cloud computing is when you stick it all out there, you don't have any choices. You have to actually do something that particular way. So it kind of restricts in some ways flexibility for the consumer to do things the old way. But it's kind of like what people have been saying for years. You got to get on a computer. I mean, if you're not on a computer today, you're left behind, which will end up happening in another 5 years. If you're not using cloud infrastructure, you're going to be left behind. Because you won't be able to buy software for your computer anymore. It won't exist. You're going to have to go with the flow. So there's some resentment with that until security becomes well-defined, until we get confidence in the security of our data and confidence in that it's going to be used the correct way, blah, blah, blah. You think a bunch of reasons why. I can come up with a million reasons why people would be initially adverse to the concept of sharing everything in their life. So, major issues. So using the cloud infrastructure, you pay as you go, pay on demand kind of computing, and then people would think about this and go, wow, it's great, right? But that's why we buy computers instead of renting them. Because that's why people buy cars instead of renting them. You end up paying more. It's good for the companies. Just how e-commerce is really good for businesses, not so good for consumers when you think about it. So anyway, you can also see it as a capital savings, Maybe instead of a capital investment, you're doing a service-oriented investment. So kind of like leasing equipment, I guess, instead of buying it for a business. Clients can put their data on the platform instead of on their desktop or on their PCs or on their servers. They can get it wherever That's the best thing about Gmail, actually, is a cloud application, which it really is. Nobody ever called it a cloud, but it is seriously a cloud application. So you can, in fact, what I'm going to do probably on the finals, for you guys are going to answer this question correctly because you're sitting here listening to me, but I'm going to say, name some cloud applications. Gmail is a cloud application. Google Maps is a cloud application. All these things, PayPal is a cloud application. I'm not going to have you, let me make sure I know what slide, number 15. I'm not going to go back here and ask you to do this for me. I'm not going to ask you the layers. That would be way too much. But you can kind of see where in the different layers, what is referred to as the application, if it falls into the particular layering and it uses the infrastructure, it's a cloud thing. It's part of the cloud. See, over here we have PayPal, we have Gmail up here, Google Maps as services that riding along applications. What's an application? Well, the application is an SMTP server, or it's a utility, a geographic database or something, or a utility that rides on top of the platform that's hosted by a grid of computers. So yeah, now actually you can go around telling everybody you know everything about clouds. You know what a cloud application is? The funny thing is it's just a word that turned into a concept that has already existed for years. There's nothing new about cloud computing, actually. Absolutely nothing new about it. It's just a new word. Why they call it cloud? I don't know. I've already gone through that route. So anyway, you put your data on the cloud so you don't have to carry it with you. And you put your applications on the cloud, and you use the server on the cloud to process the data, manipulate everything. So the guy sitting in the airport with his notebook computer who says, oh, the plane's going to be delayed. So he opens up his Windows Live. Let's go to the cloud. That's because all of his recorded television shows and everything is out there on the shared server. So he doesn't have to carry it with him. What they're not telling you is he's got a computer. He could have very well just put it on the computer. And what if he doesn't have a good internet connection? Which is one of the reasons right now, in terms of, not a benefit, I'm going to the wrong slide, because we don't have any of the disadvantages. This slide set is very leaning towards benefits and advantages. One of the disadvantages, the reason why we don't see a nationwide implementation of this, how are you ever going to guarantee internet access everywhere? How are you going to get a strong enough, wide enough bandwidth to support the utility of streaming audio and video from a shared server? If you put it on your computer, you have it on your computer, not on the cloud anymore. You're jumping off the cloud, essentially. But sometimes you need to if you don't have the bandwidth. You don't want to be on it. You don't want to have an internet connection like that. So, all right. So the term cloud is used to describe and to reflect this class of internet-centric computing infrastructure. Being transparent. Hopefully, we see that already. Users don't need to know that they're what's behind the scene, what's going on. It's highly scalable, on-demand, pay-as-you-go, pay-as-you-need. So those are some of the characteristics. Because I know I'm going to ask you at least one question. It's going to say, the first part of it's going to be, what kind of applications exist. You guys are writing this down. You're good. The second part, what are some of the purposes and benefits of cloud computing? And some of my other classes, people have been asking, what's going to be on the final? How many on the final? Probably going to be multiple choice. However, this class is small enough. The strategic management information, small enough I can probably give you a short answer. If you're taking some of the other ones, you're not going to get short answer, you're going to get multiple choice. But this one's small enough, we can efficiently grade a short answer, which I prefer over the multiple choice, because it actually is better for you, because it allows you to, there's multiple right answers in that case. And in multiple choice, there's only one right answer. Plus, I have to make the questions hard enough to make it worthwhile for you. This I can make easier questions. But the purpose, the benefits, what does it provide the user in terms of why wouldn't anyone want to use it? And after many years, cloud computing is today the network-based computing over internet. I don't know. It's really poorly worded, but network-based computing over the internet. We've had the concept for years. Okay, cloud sourcing. Let me give you a brief overview, and this will all change, so it makes no sense to kind of learn what companies are involved in this today. However, there's only a couple, and there's only a couple really good services that are out there. So it's becoming, why is it becoming a big deal? Well, it uses high-scale, low-cost providers. It makes computing inexpensive. So a lot of companies are taking the cloud option because it's affordable. And they can write it off as a business expense rather than a capital investment. They don't have to buy a huge network system. So as an example, ITU uses Gmail. It's a service. They had their own itu.edu exchange mail server, got rid of it, went to Gmail. In fact, a lot of companies have gone the Gmail route because they customize it. So they're getting a service, it's really Gmail, but it's itu.edu, and it's very common, actually. Not bad. Anytime, any place, access via web browsers, you can get to the service, to the utility. Rapid scalability, so we can add people on, take people off easily. We don't have to buy another web server, worry about bandwidth or anything. And you can forget the need to focus on local IT. If we have a problem, you call Gmail. They fix the problem for us. So we don't actually have to maintain it. We don't have to worry about it. In fact, even the website's serviced outside. So somebody else actually, they just bought server space, I think, or rent server space. I don't think they have it. They have it controlled internally. So some concerns: performance, reliability, and service levels. How can you guarantee an acceptable level of service? We're just lucky that Gmail works, actually. What if they went down? Who are we going to complain to? We have no control over the service anymore. Everybody in the company would be out, essentially. Control of the data in terms of security, the service parameters. Who owns the data? Or who's going to own, it's a service. So, who's going to provide security for the data? Well, you think they're going to do it. As we've seen, they don't do it. And they use the data like it's their data. So, application features and choices. We don't have any choices. When we use cloud computing, we use anything, we rely on what they're going to give us. So those are the features. If we want to, pick and choose what videos we want to save, we may not have a choice. We might have to save everything. Interactions between the cloud providers, well, there isn't any. This cloud is separate. then this cloud is separate. Then this. That's why I say, going back to the beginning when I started mentioning the cloud concept and who are the players in the game, we're going to end up with one. We have to have one, which is going to be Google, because they have the biggest market share. Could you imagine this cloud is separate from this cloud? Different companies, different platforms, different clouds, no reason why they need to communicate. Not the case with other services like cellular service. Just because you have a Verizon or an AT&T or a T-Mobile phone doesn't mean you can't communicate with others. You can still communicate across the network. You know, you've got your Verizon network, but your Verizon is connected to AT&T networks, to all of the other ones together. Not the case with cloud computing. Very separated, because it's not the internet. It's an infrastructure that's riding with support of the internet, but it's a separate concept. It's utility computing above and beyond what the internet would give you. Because the internet is really 1.0. This is really Web 2.0 technology. And the internet is involved, but it's not the platform. Interaction between cloud providers, yeah. Okay. No standard API, a mix of service-oriented application development, REST. So we have no cloud platform. There's no multi-cloud compatibility, no APIs, privacy, security, compliance, and trust. The whole cloud concept relies upon trust. And here's the problem. We have all of these. This is where we're on, actually. This is what ITU uses. We're on a cloud. We have Amazon servers. That's where the itu.edu is stored. And not bad, because you can get grids. You need more space, don't worry about it. We just make the grid bigger, give you more grid space. And we got GoGrid. These are all separate companies. Sun, all different people. So the commercial offerings are proprietary and usually not open for cloud systems research and development either, which is why we don't have any cross-cloud platform compatible APIs, nothing tying it together. Another problem that we're going to have in the future that's going to need to be fixed. That's why I say one of these guys is going to win. You're going to take all the market share. And we'll see what happens. So we have the cloud taxonomy. Well, we have infrastructure services, platform services, cloud software services. Won't expect you to read everything that's on that slide. But here, actually, I can make it a little bigger for a second here. Actually, because this came up on the lower, we'll look at software services here. Billing, open source, op source, billing, financials, legal, sales, CRM. These are in terms of software that you can use. This is where I would say Salesforce.com would come into play, CRM software, things of that nature. What we're looking in terms of this taxonomy slide, because you don't really need to know the details of it, are different categories. So we can divide it out in terms of, is it a cloud software application? Is it a cloud service? Is it an infrastructure service? Is it a platform-related hardware service? Is it a platform service? So it doesn't really matter because it really is all the same, but there are different ways of describing the different components and different pieces that are in there. Cloud storage. This is where this is our Amazon's, our storage, kind of like buying web space. We have a server that the IT website sits on an Amazon service that housed by somebody else, managed by another company, but it's a cloud-oriented environment. So when we talk about the cloud as riding on top of it, we're not just this server, just that server, just that server. Instead, we can span. Gives companies like, example, people that have websites like itu.edu, gives them the ability to grow, downsize, or upscale, and at will, without any investment, without any further problems. So in terms of the storage, we have several large web companies, Amazon, Google, and now exploiting the fact that they have data storage capacity and that they can hire out to others. So we have capacity being resold to other smaller companies. So you can actually kind of go through middlemen to get your data storage. Which is interesting. The approach is known as cloud storage. So that's what's called cloud storage. Allows data stored remotely to be temporarily cached on local desktops, local computers. mobile phones, internet, linked devices, and things of that nature. Looks like it's local, but it's not. It's kind of like Apple's iDisk or remote disk. I think they call it iDisk. I don't know. Where it's on the internet, it's not stored on your computer, but it looks like a drive on your computer. But if you're not connected to the internet, you can't see anything on there. But you do see what's cached. You have that appearance of it still being local, even though it's gone. So it's just not accessible. In fact, I believe you can read from it, you just can't write to it while you're not connected. Which makes sense if you're going to store files there. So, here we go. This is what ITU actually uses. ITU uses the Amazon Web Services. It's just service space that they're using, that they're storing all of the CSLO essays on. All your assignments you're uploading, everything's being stored on this server, essentially. Amazon Web Services. This is just a bunch of, I wouldn't say marketing stuff, but you don't really need to know the specifics about the services. I put this in there for people who are like curious about it. But plus, this is a standard kind of presentation. So, Amazon simple storage service, unlimited space, scalable, fast. You just say, "Oh, give me some more space. Give me some more space." In traditional networking environment, you really can't do that. You don't pay per megabyte. You normally pay for drive. Add another drive on there. We have 2 gigabyte drives or something when you're building it yourself. So, utility computing. And so what we end up now with are different categories or classes of servers. So what I've been showing you are pictures and examples of storage. We also have application servers. The application servers are what's storing, as an example, the Google apps, the Google Maps. The Gmail servers are applications that are specific towards the service that they're providing the user. So what ends up happening is you get access into the application servers through an account. So when you do Salesforce.com, you go into their application, their interface. You go through the CRM interface. You go through the Gmail interface. And the server part of the cloud is just providing you the application instead of storage space, essentially. Elastic, I'm actually going to kind of skip through some of the specifics on these services because they're all going to change a year from now. So, opportunities and challenges. So the use of the cloud provides a number of opportunities that we've seen to enable services to be used without understanding how the infrastructure works. You don't have to go out and buy a bunch of equipment. There's no capital investment. You just subscribe to the service. Works with economies of scale. Small businesses, big businesses, we can all use the same thing. We're not limited in terms of the entry into the cloud. Potentially lowers the outlay expenses and the startup costs. And the cost would be based on demand, so it's on-demand pricing. So it's a service. And vendor service providers claim that the cost is established by ongoing revenue streams. So, what you're getting, in fact, if anything, as a consumer, you probably would be better off just buying it one time than using it, paying for its use month after month after month. You end up paying more in the long run. You just think about how much you've paid for your cell phone over the years. Will probably make you sick after a while when you look at that and go, $10,000, what? I could have bought an entire cell phone company for that. But every month it's like $59, $60 or so. It adds up. That's why I say just buy your phone. There's some people that don't like it, they go, oh, free phone, but they pay for the service. It's like it's more expensive to do it that way, especially when you get a 1-year, 2-year contract. Just buy the phone, and then you're not locked in. You get a lower rate on your service, and it ends up in the long run, it ends up costing you less. Sometimes it ends up costing you less. Data services are stored remotely, but accessible from anywhere, so you have that anytime, any place access to your data. And so opportunities and challenges, those were the continuation here. So we have, in parallel, there has been some backlash against the cloud computing. Obviously, I've told you some of it already in terms of security. Use of the cloud means dependence on others. So your entire business is riding upon somebody else. And if that somebody else goes down, you're out of business, essentially. And you might not have you have limited flexibility and innovation as well. You don't control it, so whatever features we're giving you is what you're going to get, kind of thing. The others are likely to become bigger internet companies like Google and IBM. So they might monopolize the market. They might go away. You might have invested all of your energy into a cloud that's gone. Or, some agree that this use of supercomputing will return. Mainframes are going to come back, as PC was a reaction against the entire concept to begin with. Who knows what will happen. Security could prove to be a big issue. We've actually seen security issues already, so it's keeping a lot of businesses. And clouds actually, believe it or not, are focused, or have been traditionally focused on business customers, which is interesting because now they're pitching it to consumers, the whole to the cloud stuff. And even there's one with a picture, she's taking a video camera from her video camera, she's putting it on the cloud. It's like these are kind of, utilities that are traditionally not pitched towards consumers because businesses in large scale use can basically have more of an advantage. It's really only your tech-savvy user who's going to want their pictures available everywhere. Otherwise, when are you going to use your pictures? When you're at home? So, a lot of people actually are going back to printed pictures. A big trend right now is to go backwards. Not necessarily with the film. We don't have to use camera film, but now we can just have them professionally printed like real pictures. Not on a really low quality home printer, but like at a photomat, or like a Costco printing kind of utility. So a little higher quality. All right, but then again, it depends on the quality of service you're getting them printed. Many issues related to policies and access as well. So if your data is stored abroad, those some policies. What policies are they adhering to? Are they adhering to local country policies or policies elsewhere? As for copyright infringement, problems of that issues might come up. What happens if the remote server goes down? You call them up and say, hey, I lost my connectivity. Not like when your cell phone goes down or something. You don't have a choice. And how you can access your files. It's nice when you can have another, if your cell phone dies, no problem. You can just use somebody else's cell phone. If you're running your business off of a cloud, the cloud goes down. Or your connectivity to the cloud goes down. You might as well just shut your doors. You're not going to be able to do anything. It's not like you can borrow somebody else's business or something, somebody else's computing resources. So there have been cases when users have been locked out of accounts and loses their access to the data, lose your pictures, lose your videos. Now, from a consumer's point of view, no problem. From a business perspective, it might be a problem. So the advantages of cloud computing, why do you want to do it for strategic management? Lower computing costs. It allows a small startup company to be big overnight, and it lowers the costs all around. You don't need high-powered, high-process, high-priced computer systems at all to run this. And it actually will set up servers for you for web applications, for sharing data, for email. Everything is given to you automatically. So it really does reduce down the amount of work that you actually have to put into your IT infrastructure as well, because it replaces your IT infrastructure. However, there's no strategic management of it. There's the selection of the services, and you might have a bigger selection with a cloud environment than you would if you were purchasing these things on your own. But you're using what everybody else is using, sharing what everybody else is sharing. So you don't have any competitive advantage, you just have lower startup costs. When you're using web-based applications, your PC can be less expensive, with smaller hard drives, less money, more efficient processors. So. Your PC is this scenario does not even need a CD or DVD drive. Actually, you don't need anything. So we can actually go backwards and come down to dumb computers, dumb terminals. In fact, I haven't seen it yet, but I'm waiting for this product to come out on the market. It's a complete cloud, right? Where everything is on the cloud. It's like a cell phone. You turn your cell phone on, you get instant applications and stuff. Why don't we have a netbook that's, really thin, that's just a monitor and a keyboard and a network card? What do we need a hard drive for? What do we need a DVD drive for? We don't need any of that stuff. You turn it on, it automatically goes to the cloud, loads up all your applications and everything for you, and you use it. Because what do you need a netbook for? The big screen, the keyboard? So I'm waiting for that product. I don't think I've seen it yet. The netbooks came out on the market, but they're fully running systems with XP, with an operating system on it, with hard drives on it. But do we need that? And so if someone comes out with a computer that works with a cloud, that does everything for you, that actually you could fold it up, put it in your pocket or something. I mean, it would be nothing to it outside of an LCD screen and a keyboard that you'd carry around, and you'd access your cloud information, run Microsoft Word, PowerPoint, do everything you do on your home computer via the cloud. So there was a thing on I think it was a Discovery Channel, no, Channel 9, KQED, the local station, on that very concept of, which is the concept of the dumb terminal. Because in the old days, what we had was, a monitor, but the monitor was huge, because back then monitors were big, and a huge keyboard. You turned it on, and inside the keyboard there was a little network card, and you had a network cable hooked into it, and the keyboard connected, the monitor connected to it as well. Long story short, it was dumb because it didn't have anything. It didn't have a hard drive, didn't have anything, it didn't have memory, it had nothing. It's just a receiver. Which, if we're going in that direction, they should start building notebooks like that, essentially. But could you imagine, actually, you know what, even for those people who like to save stuff, that's what the thumb drive could be used for now. A portable thumb drive, maybe plug the thumb drive into it. You can store your files on the thumb drive if you want. You download something, you want to keep it, you want to take it to another computer. Actually, theoretically, you shouldn't have to do that either. It would be on the cloud. Your other computer would connect to it as well. You'd have it everywhere. So, I don't know. It might revolutionize computing, actually. Perhaps in the future we won't have computers. We'll have interfaces, keyboards, and it would be nice to be able to get to everything from my watch or something, or from another device. Have all my electronic devices connected together. So. Some more advantages: improved performance. Yep, a few large programs. If you load Windows, old versions of it, in fact, that's one of the age-old problems with operating systems. How do we make the operating system more efficient? Over and over and over through time, we're putting so much more demand on it. We have to have so much more memory on it, caching systems, bigger hard drives to support the applications, to support all the work we're doing. Why do we need that? Because take a cloud as an example, you can improve performance immediately by removing all of the requirements for all of that stuff. And now you have a pretty fast working system. So, yes, actually, thank you for taking the initiative to start that attendance roster. Because we're getting close. We're gonna end after this. I'm just gonna cover cloud computing today. So. Reduce software cost as well. Actually, in terms of improved performance, we can get rid of those large programs hogging up all the memory. And the system boot might be faster as well if it doesn't have to boot up anything. It's not booting an operating system, it's just connecting to a cloud. It will boot as fast as your cell phone boots, essentially, which is what your cell phone is doing. It's booting up, loading its own operating system, but it's establishing a connection to the network. And that's where most of the time is being spent. Reduce software costs. You don't have to buy software anymore. You just go out there and use it. We don't buy software for our cell phones. We download it. From to the cell phone. In fact, most of what we're downloading is not even on the cell phone. It's a service-oriented cloud application that we're connecting to. It's giving us the connection point to it. We're not really installing that much. That's why that stuff installs so easily. Most of it does, I should say. Some of it doesn't. Some of them are real applications that are running on the phone. So that's right. Most cloud computing applications today, such as Google Docs suites, are totally free. No expense, which is the huge selling point for a lot of people, businesses. You can get a lot of stuff for free, and it's all better than paying $200 plus for Microsoft Office software. You can use OpenOffice.org. You can use Google Docs. You can use all sorts of different things that are free online. So, instant software updates. For those of you who just enjoy watching your computer, waiting for your computer to update itself constantly, no more updating. Because there's no need to update anything locally if it's not stored there. So it doesn't take. So there's no longer facing having to choose obsolete software for higher costs, lower costs. Everything's updated automatically. Nothing will happen automatically in the background on your computer. Improved document format compatibility. If everything's being shared on the same server, then everything's going to be in the same format. You're not going to worry about different versions of different files or anything, or different programs. Everything should work interchangeably, you think. So you don't have to worry about documents you create on your machine being incompatible with others. Unlimited storage capacity. Even on your hard drive, on your computer, you have so much hard disk space. You fill it up, you're done. You buy a new computer now. You get rid of some of the crap and you make room for new stuff. But you don't actually have to get rid of anything on a cloud because it's there for you. Increased data reliability. No backup needed. It's already backed up. So the cloud is managing the storage, managing the retrieval, managing the security, doing everything for you. So you don't have to back anything up. How many people actually back up their computers? People used to do this a lot in the old days. Now people let it go. People just let the data get lost. In fact, it's a relief because then they can start fresh with a new system. They don't have to worry about all the old garbage that was on there. So unlike desktop computing, the hard drive crashes, destroys, the computer gets broken during an airport security check, falls down on the ground. Don't worry about it, just buy another one. Still got all your data because it's on the cloud. So, which is not bad, actually. Which is why that iDisk or some of the Apple products are actually kind of good. Because, in fact, it's easy to transfer. Not even part of the advantages here, but every time someone buys a new computer, people spend most of their time getting this stuff off their old computer, putting it on their new one. In this type of configuration, you wouldn't need to do that at all. You just turn it on, and it's just like your old computer now. It's your new one. So why would you actually have to buy a new one then? Think about it, unless the old one was broken or something. Universal document access. So kind of like what cell phones are doing now, you can look at PDF files, Word documents, Excel files. So instead, documents actually stay on the cloud, and you can access them from anywhere. So latest version availability. You don't have to wait for an install of something. You already have it. So you always have the latest version of everything. Easier group collaboration, which is why people are so worried about security. Actually, I'm surprised people don't complain about Google Docs, because although you have a login for it, theoretically, it's login protected, it's still stored on somebody else's server. Still accessible through other applications. I don't think it's accessible through search engines, but who knows, maybe in the future. Nobody ever deletes it. So for people who are paranoid about deleting things, I don't think you can ever delete anything from the internet, seriously. Which is a lot of people have had problems with Facebook, putting up old pictures and then deleting them and noticing that they're still there. Like they still show up in search engines, in hits on search engines. So it's like, hey, I deleted that account, I deleted all the pictures, but hey, look, it's still here. Interesting. But that promotes group collaboration as a positive, and sharing documents leads directly to better communication, better collaboration, hopefully. Many users do this as important advantages for cloud computing. Multiple users can collaborate easily on documents and projects, which is why people use Google Docs. So the documents are hosted on the cloud, not on individual computers, so you don't have to pass them back and forth. No email exchange. So it actually cuts down on the amount of data that's passing over your network. Believe it or not, it makes things a little bit more efficient. And they are device independent as well, so you can load them anywhere. So no longer tethered to a single computer or network system. Get them on the internet, get them on the intranet, get them on your cell phone, get them on the computer, same documents, shared among everybody else. So you can move to portable devices, applications and documents are still available, even though you may not necessarily have the same utility that was opening them. And you might have a reader instead of a full program or something. In fact, you might even take that document, merge it in with something else, and not even use a reader, just use another program to actually open up that document. So let's see, disadvantages of cloud computing. In fact, this is the #1 problem. It requires a constant internet connection. So that's something characteristic of Web 2.0, which is why we're still on 2.0. and we haven't made it to 3.0. Until we can guarantee a constant connection, we can't guarantee applications that are going to interface with the internet in the real world to be seamless. When the internet goes away, we don't have a constant connection. And 2.0 is made possible because of DSL and high-speed access, where applications can push information to users through applications. Servers can push information to users via applications, and which is essentially what the cloud is doing. But again, it's heavily reliant upon connection. So cloud computing is impossible if you cannot connect. Since you use the internet to connect to both your applications and your documents, you're hosed. So you're a student, you have a paper due the next day, but your cloud is down, or your service is down. As a student, I think I would rather have the old-fashioned computer, where I can actually write the assignment, do the homework, print it out, in privacy of my own home, take it with me and give it to the teacher, which you can't do if you're using a cloud environment, which is, I think, why a lot of people are hesitant to actually putting all their documents and stuff out there. A dead internet connection means no work in the area where the internet connection is going to be offered. And when you're offline, cloud computing does not work at all. There's no online, offline. It's all online. So you don't have any offline option. And it does not work well with low-speed connections or congested networks. Same problem, low speed. Going to be an issue. So similarly, if you don't have a high-speed connection, it's painful, actually. Painful to watch something load. It's kind of like digital cable, actually. When the digital line is having issues, the whole picture goes in pieces. And sometimes you see little pieces that shows up, and sometimes it stops. Or the whole thing just doesn't work correctly, because it needs all of the bits and all of the pieces to formulate the right picture. Web-based applications require a lot of bandwidth. Graphics require bandwidth. Multimedia, large documents, it's very bandwidth labor intensive. So if you're laboring with a low-speed dial-up connection, which hopefully nobody has these days, but now what's ended up happening, some of the DSL connections aren't fast enough. So in the old days, if you had dial-up, you upgraded to DSL, digital subscriber lines, and that was good, right? Now you have to have cable modem these days, high definition, high-speed cable, in order to be compatible, especially as more data ends up becoming part of the picture. So in other words, cloud computing is not for broadband impaired people by default. Well, the cloud can also be slow. You're wondering, why can it be so? Well, it's not the internet connection that's slow this time. Instead, it's the applications that are running on the server simultaneously. Just like your computer slows down, the more applications you open up, the more things you're processing, everything runs a little slower. Imagine millions and millions of people in high peak times of the day using the cloud. The cloud's going to slow down, and it does. Actually, the clouds that are up there right now slows down significantly. So even fast connections, the web applications themselves, sometimes a slow processor, slow running application on the cloud is going to be slow. Everything about the program, from the interface to the current document, has to be sent back and forth from your computer to the cloud. You're just looking at a huge bottleneck, worse than if it was running on your computer. Because you send your computer, you can start closing things down. You have control over what's running. In the cloud, you can't tell, hey, get off the cloud. You can't boot people off the cloud to make it run faster for you. Not going to work that way. Features might be limited. So far, not an issue, because hardly anyone's relying upon the cloud as their sole source of computing. But when you start going in that direction, you're relying upon what features that particular service provider is going to be offering you. And they may not give you exactly what you want. On your computer, you can customize exactly what you want. On your own server, you can customize everything. So the situation is bound by change. But many web-based applications simply are not as full-featured as desktop applications as well. In fact, we see this with web. In fact, if you haven't noticed, there's applications out there that allow you to open up and edit Word documents, PowerPoint, Excel, for people who don't want to buy Microsoft Office. But the features are limited. They're not giving you everything that's included with Office. They're only giving you the ability to open to edit, to save. And they're cutting down on the features to make the application run faster via an internet connection. So what ends up happening, is, especially with other applications, is they cut down on the features to make it simple, make it controllable via a web interface. It doesn't give you full features that you would get if you wanted to install stuff on your computer. If you installed Office on your computer, you're going to get everything, spell checker, everything. And a web base, you're not going to get as much. Essentially, is a long story. So here's another example. You can do a lot more with Microsoft PowerPoint than with Google Presentation. What the Google Presentation is actually Microsoft PowerPoint stripped down. So I don't know if anyone's used that. Most people have used Google for Excel or Docs. So. And basically they're similar, but the cloud applications lacks many of the PowerPoint Advantage features. So if you're a power user, you might want to leap into the cloud computing. You might not want to leap into cloud computing just yet because all your power features are going to go away. Lo and behold, there are more disadvantages. So what do we have? Stored data might not be secure. I've covered that point already, I hope. So how secure is the cloud is a huge question we don't know yet. I can't even answer that for you. And unauthorized users, can they gain access to your information, your confidential data? I'm not quite sure about that one yet either. Only time will tell how secure the cloud actually is. And I think it's an area of trust. I think once people start trusting it, people trust Gmail all the time. It took a lot of people a lot of time to kind of get used to the concept of sharing all of their personal information. And some people just don't even realize that they're sharing all of their personal information. But yeah, everything, all of your emails, everything about everything you have emailed back and forth is public knowledge on the internet. Which is interesting because companies are on Gmail. So all the IT correspondences are public knowledge, theoretically. Although there is some lightweight security on it. Storage data can be lost. Oh yeah. So it's nice when it's there, but it might go away. It might be archived. It might be moved. Oh, we lost that. Oh, no problem. Kind of like the bank losing records and things. Because you're not controlling it, somebody else is. Theoretically, data stored in the cloud is safe, replicated across many different machines, but there's an off chance that some data might be missing or corrupted or destroyed. HPC systems. So not clear that you can run computer-intensive HPC systems, open MP systems, or other types of systems, scheduling systems, important for different types of applications, virtual machines located to minimize communication latencies. Different compatibility issues might actually might be a problem with different types of high processing systems or different types of environments that might exist. General concerns using different protocols, different APIs. Might be impossible to run applications between cloud-based systems. In fact, as I mentioned before, this is where we're getting at in terms of, we're probably going to narrow down to one kind of cloud that's compatible, because right now you can't communicate between different clouds and different cloud systems. And you can't run high-powered anything application-wise and expect it to actually connect with multiple clouds. It's just not going to work. So let's look at the future. We thought the future was now, but we have more in the future. So the future isn't now. Many activities loosely grouped together under the cloud have already been happening. So we have centralized computing going on. We have activities to new phenomena. We have grid computing, where we get on a grid and we share servers, sets of servers. In fact, a lot of companies are going to grid centralized computing. And in order to understand basically how the grid is working, you kind of have to have a little bit of a networking background, or at least know what the term client server is referring to. You guys know what client server is? No, you're not familiar with client server. You guys are business students, though, so that's why. Client server. Server. Client, all connected together to a centralized server. So with grids, it's not just one server. It's a whole bank of servers that are all connected together that you have access to. So when you go into the grid, you're not going into just one of them, you're going into all of them. And that you can, with a grid, you can actually kind of share power, computing power among all those different servers. And you can run applications that span over the multiple servers in the grid. So when you need more power, you just add another system to it. Add another server, add another server. And you can break stuff off to do load balancing and stuff like that. So it allows a lot of flexibility in terms of the way the server is sent into it. It doesn't change the client at all. It's just server-oriented. So whether these worries are grounded or not or have yet to be seen in terms of concerns. And mainstream adoption of the cloud computing could cause many problems for users that they might be worried about. Many open source systems appearing that they can install and run on your local cluster should be able to run a variety of different applications on these systems, but hopefully in the future we'll have more open source development in terms of clouds. Right now we don't actually have any open source cloud anything. We have some beta stuff out, but nobody's really put it into production yet, so it's kind of an unproven technology at this point. So now's your opportunity for questions. So hopefully what you wanted to get out of this is business people looking at IT as an infrastructure. Can I use a cloud for my business? I say today I wouldn't jump on the cloud right now. Of course, I'm conservative. If you're a startup company and you don't have any money and you want instant power, computing power, and you want to look like a big company overnight, jump on a cloud and get a whole grid and look big overnight. But then later on start thinking about security, start thinking about storage space. You can use applications that are on the cloud instead of buying applications in-house without actually moving all your computing power to the cloud. You can use utilities. Use the cloud like utility-based computing, which is what a lot of people do with Gmail. So you're a small company, you want to have email for your entire company, you go to the Gmail route, you get private corporate emails on the Gmail cloud server, everything works great for you, and then you decide to use Google Docs, and then you decide to use all these other things. Eventually you're on the cloud. Eventually you're off. All of your stuff is local, is owned by Google essentially. So outside of that, you could build it yourself. You could put together your own network. But usually that's not necessarily a choice for new startup companies that may not necessarily have the resources or the technology or the in-house specialists to do it. You're a business company. You're not a bunch of technical people who know anything about networking. Then I would say cloud's probably a good option for you. A lot of skepticism to it. A lot of people have absolutely no idea what it means. It started out in the business community. It's starting to make its way into personal computing. I don't think it really has a place there. But we'll see. The future, we'll see what happens. So that is everything I can tell you in terms of cloud computing, which kind of sums up that lecture, which is kind of a good stopping point, actually. So next time we'll cover something completely different.